I had no problem like doing it. I'm just going back to figure out what to do if there are characters that occur the same amount of times.
Ah, great. That's a good edge case, right? So the edge case that Jay's bringing up is like, what? How should I handle characters if the same, or if there's two different characters that occur or tie for the most character, most seen character? Uh, that's a great clarifier, right? Because depending on how your interviewer feels, could be a very different problem. Maybe it's the character that showed up first in the string in that case, or maybe they just say, "Oh, that won't happen," or they say, "Just give me back one or the other, or give me both," right? So there's all these different tweaks that you'll have to make on your algorithm. What else? What else? What else do we think about this warm up?
Um, I kind of just used this one with when you were helping me yesterday with the sum two. You were kind of iterating how you have to use an object so it can keep track of everything else. So I kind of used that object example to kind of try to keep track of all the count so it can return the largest count or the letter with the most count. I got it to
Awesome.
work, so it's pretty decent.
Nice. Yeah. Raise your hand if you on the nonverbal feedback feature, if you use some kind of object to keep a count of everything. I think there's a hand raising thing, but you can also just say yes. I guess that's fine too. Okay. So looks good. Most everyone did. Good. So whenever there's like these counting problems, that's generally one of the first things you should be thinking about. It's like, hey, can I use an object to help me keep track of things? Sin, you're asking if I wanted a function to take in a string and a letter, and Henry's confirming, yep. So that is not what I asked for. I asked for a function that takes in a string and returns the most repeated letter.
I was agreeing with Rafid.
You're agreeing with Rafid. I'm sorry, Henry. Then I'm just embarrassing Sin. Sorry.
My God.
No, it's okay, right? Reading these problems is something that definitely comes with a lot of practice. Sin is saying that you were agreeing with him. I like it. I'm agreeing with everybody. I should be the only one to be embarrassed ever. So, right, reading these problems can be tricky. They can be kind of weird, kind of funny. It's really important to read problems and think, what is the input? What is the output, right? What is the type of output, right? Are they asking for elements in an array? Are they asking for indices of an array? Are they asking for a number? Is it a Boolean? What am I actually returning? And your whole function should be based around essentially that kind of idea. And then it's just, how do I move this input into that output? So let's go over this problem. And then we're going to have a miniature lesson on what linked lists are, because I'm pretty sure we know what they are. So it's just going to be like a light review. And then we're going to do a linked list practice problem. And then seeing on time, we're going to do a light review on stacks and queues and do a practice problem probably on those. Okay? Rock and roll. So let's go take a look at how I might approach this problem. You can all see my screen, correct? Thank you, Jenny, for the nod. Okay, so we are writing a function that returns the letter, and so we're going to say const most, I don't know, occurred letter, horrible name maybe, string. It's going to take in a. We know we're going to return something, but we don't know that letter yet. We don't know what it is. So, right, there's lots of ways for us to do this, but I like the idea of us using an object in some regard, right? So let's go ahead and say like let counts, whoops, and we can just make that an object. So we can then go ahead and iterate through this string and check to see if our counts object holds this character or not. If it does hold the character, I'm going to increment its count by 1. If it doesn't hold the character, I'm going to add that key to our counts object and go ahead and set its value to be a count of 1 because we've just seen it now one time. Okay, so let's go ahead and try that. So I'm going to go ahead and use a for of loop because I don't have to worry if I'm going to go to string like less than string length or string less than equal to string length. And since I don't care about the indices in this problem, I can just go ahead and use a for of loop. And that way I'll just have that character right off the bat. It's a little bit cleaner, a little bit shorter. But this is only good if I don't care about the indice. So I'll go, okay, great. So I can just kind of do like a quick, like, hey, if my counts has a character, so this is going to either give me back undefined or it's going to give me back the count of how many times this character has occurred, right? So we can go ahead and just say, okay, if character has a count, so this is in the event that it has it, I can go ahead and increment counts at character by 1. So I can just go ahead and do plus plus, or I could do plus equals 1. Those are synonymous. Else, let's go ahead and set our counts to 1. So I'll say counts, and I'm adding a key into my object at the value of 1. Okay, so let's go ahead and first just test to make sure this much of our code works. So I'm going to go ahead and just return for now our counts object. And let's go ahead and check it. So I'll say console.log most occurred letter, and let's just go ahead and put hello in there. And we should be getting an L back, would be their goal, our goal. So let's run node warmup.js. And we get this object where H is 1, happens 1 time, E happened 1 time, L happened 2 times, and O happened 1 time. So that's a good enough test for me to know that my object is working appropriately. So, okay, great. But I need more than that, right? So I also need to find who's got the biggest value. So, okay, what do we think? What's a way that I could do something like that?
You can do another, like another let character of, instead of string, you could do like a character of the actual object itself. So now you can go into the object and see which one of those has the most letters.
Yeah, that sounds great. So I should loop through the object and be checking to see who has a higher value count. Is that the highest value count? That's essentially what you're saying, yeah?
Yeah.
Okay, great. So let's try that. So I'm going to go ahead and say let max character. And I don't know what I'm going to assign it yet. And I'm also going to keep track of let max character count so that I know each character's count while I'm going. So I'll just set that to 0. I think it will make sense why I'm doing that in a second. So first things first, let's go ahead and say for let key in object. So this object is called counts. And this really is also character, but I'm going to leave it as key for now. And I'll say like, okay, hey, if my counts at key, if that's greater than my max character count, I'm just going to go ahead and update my max char to be what my key is. And I'm going to make my max char count equal to my counts at key. So if I do something like that, we'll be checking and we'll say, okay, is this like, so in our hello example here, we say H has got 1. So this is, it's going to produce a 1. And it's going to say, hey, is that greater than our max character count? So our max character count is currently 0. So we're going to go, yep, it is. So our max character, this should be max character, sorry. So our max, it keeps autofilling, that's why. So our max character is going to be set to H, and our max character count is going to be set to 1. Then we'll move to the next letter here, our E, right? And so we say, okay, counts at E, this evaluates to 1. Is 1 greater than max character count, which is currently 1 with our H? And we'll say, no, it's not. So we're just going to keep moving. We go to the L. Counts at the key of L. This is going to evaluate to the number 2. Is 2 greater than our max character count, which is currently 1? Well, yes, it is. So our max character is going to be assigned to the key, which is L, and our max character count will be the 2 that it evaluates to. Same thing will happen for O. Counts at the key of O. That's going to give us back evaluate to 1. Is 1 greater than 2? It's not, so we're going to keep moving. And at the very end, we should be able to just go ahead and return our max character. And this should be our L. So let's go ahead and test. And it is. And so this works. So how can we maybe make this code nicer? Any ideas? Brandon, I am sharing my screen. Are you not able to see it? Is everybody else, people are able to see the screen, or am I like, no one can see my screen?
Yes, I see your screen.
Oh, okay. Brandon, something is going on with your computer. Then. Oh, because you're on your phone. Okay. Sorry. I'm recording it though, so you can watch it later. Any questions on this approach, or any comments on how we can make this code cleaner?
I have a question, Corey.
Yeah, Rafi.
Just because it's been a while. What's the difference again between the care of and then key in? Like the difference between the two?
Yeah, so that's a great question, Rafi. So in is the only way. In for loops are the only way to iterate through an object.
In is okay. Let me write this down.
Is the only way. If you want to iterate through an object, you are using a for in loop always. If you use of, you can do of for an array, I think, or a string, and it actually is giving us the element, right? This is actually giving us the character of this string, while this is giving us the key in counts. So if we did a for in loop on an array, we would have the indices, because the indices are the keys in an array.
Mm-hmm.
While if we did a for of loop, we would actually get the element itself. But if you're doing a for of loop, you wouldn't really do an array. You would just use for each, right? So for of is pretty much just for strings.
Each. Gotcha.
Yeah. So for of is going to be for your strings. For in is going to be for your objects, and let I equals 0, I is less than whatever or something. That's going to be your regular traditional loop.
Okay, so for in is for objects when we're specifically looping through objects.
Correct.
For of is basically like a for each loop, but it's for strings instead of arrays. And then everything else would be like a for I equals 0, I array.length.
Yeah, for of is good for the string if I don't care about the indices and I only care about the characters.
Okay. Yeah, in this case, you were caring about the characters, not the indices.
That's right. I couldn't care less about the indices in this scenario. So
Okay.
I'm just going ahead and using that because it's just a little bit cleaner.
Got it. Okay.
Any other questions or comments on how I could write nicer code?
Question. What if there was
Yep.
an edge case with it's the same letter, but one is capital and one is lowercase?
Great question. So that is definitely another thing you should ask your interviewer of how they want you to handle that, right? Do they care about punctuation? What if you have spaces in your string? What about uppercase, right? That's definitely something to consider. I could just say like, string is equal to string.to lowercase. Let's say I want all lowercase things only. Now it will still give me back L because it's gonna turn it all into lowercase. So it still works. If I needed to do that, that would be okay. For now, I'm not going to worry about, I'll just leave it. That's fine. Any ideas on how I can make this code nicer? Or do we like this code? Does this look good to us?
What's that one liner that you do? The ternary.
Oh, a ternary. Okay. Yeah. So I could say if character count, maybe make this plus plus, else else do something like that. Yeah, that's an improvement, right? Depends on if you're going for complete readability or not, but yeah, that still works. That's not bad. What else? What else might we want to think about doing? Nilber. Great message in the chat. So Nilber says we should talk about single responsibility theory. So we can break functions into two, maybe a counter and a max character, right? So this function's doing like this part of our function seems like enough to be its own function. So let's go ahead and make that a little helper. So we'll say const, let's say count occurrences. This is going to take in our string. And what I'm going to do here is I'm going to rip all this stuff. And then I'm going to return counts. And instead, I'm going to make my let counts here just equal to count occurrences and pass in the string. Okay, so now we have these two smaller, more digestible functions. And I think that's actually the improvement I was hoping for. I'm still open to other improvements if people see them. But I was hoping for the ternary one and the concept of breaking those up. Pretty happy with that. Any questions on that? Okay, so let's move on. Stop the screen. Let's talk about linked lists a little bit. So it's good to be able to implement your own linked list, and I encourage you to do so. I was talking it over with the team today, and we were thinking about what's actually coming on the DSA test at the end versus, you know, overall DSA knowledge and ability. And we believe both to be, you know, really important. But we'll have more time to go over more DSA in deeper depths, a little bit later. And so for now, we want to kind of plant some more of those seeds, reconfirm some of our DSA ideas that we have learned, and then to focus more on how we'll be able to ace the test. Okay. So let's talk about linked lists. What's a linked list? Who can tell me?
A linked list is a way of organizing data. It uses nodes, and the nodes simply have a value, and they point you to what the next node in the list is.
That's a great explanation, Jay. Really good. Right? So the linked list is going to be a data structure for us that's essentially kind of a wrapper class on nodes themselves. So we have our nodes. And our node class has a constructor. that takes in some sort of value for our node. And then it only has a few properties. It's got this dot val is equal to val. And then we have a this dot next, which will initialize to null. Okay, so that's all a node is. And the linked list class is essentially something that wraps around this and connects it. So we can have a node here that has a val of, let's say, 7. And it just has this next property that's going to go ahead and point to another node that maybe this one has a val of 8 or something. Right, and that's all it is. And if you want to have a doubly linked list, which can sometimes be helpful because you can delete yourself if you have the node available, you can do a previous property, which is like this dot prev, and we'll set that equal to null as well. So this is like what a linked list is at its crux. Like, and it's nothing too fancy. You'll have heard in the videos of Hasib's that Sentinel nodes are helpful when making like a linked list. That's like when you've already given them a header and a tail, so that you don't have to worry about conditions of if there's a head or if there's not a head, and treat things differently. But it's not that hard if you do the other way either, respectively. So this is our node. And so let's go ahead and make this together. And then let's just practice traversing nodes. Okay, so here we are. Let's go ahead and make a linked list section, we'll say. Because typically, I mean, someday you may be asked to implement your own linked list. But more often or not, you already have a linked list and you're interacting with it. So that's where I really want to spend some time focusing. So let's say we have a class. I just have to do this so that I can build a linked list. And we'll have a constructor. Takes a val, like we said. This dot val is equal to val. This dot next we'll say is equal to null. And let's go ahead and make a linked list, right? So we can say,
You're missing an L in val in the constructor.
thank you. I share with them eyes, with them eyes, with them eyes. Let's go ahead and say let head. This will be new node. I'm just going to make this a 2. Say let next head is equal to new node, and we'll make this a 3. I'll say third, fourth. Just keep this simple. 5th, 4, 5, 6. And let's just tie these together. So I'll say head.next is equal to next head dot next is equal to third dot next is equal to fourth, and fourth dot next is equal to 5th. Okay, so let's see how this works. So let's console log our head and see what kind of information we get. Wrong one. Okay, so when we log this, we see we get this node. This is our head node, our value, the next property, and this points to our next node object, which we see has the value 3, and the next value, which points to our next node object, which has the value 4, and the next is another node, and it stops. So this, when you see your terminal saying this is just it saying like this may keep going. Just go fill it in. It's just like there's some limitations, I guess, to the way terminal prints, but this does work. All of this is connected. Okay, which brings me to my next challenge for you. I want you, and I will share this code so that you just have it. I want you to write a function that takes in a linked list, right? So this right here, this head, just for the record, represents a linked list, right? This is one, even though this is one node, it's got all of these links to all these other nodes. So whenever you have a problem and they say, oh, you have a linked list, or determine if have a function that takes in a linked list and determine if this and this, you can assume that you are given just that head node, that one node, the root node, the head node, whatever you want to call it. And it's your job to iterate through that node. And so a good way to do something like that, well, we're going to talk about it, but write a function that takes in a linked list. I don't know what that is. Linked list, and returns an array of all the odd values that the list contains. So hint, while loops, okay? While loops are really something you typically use when you're iterating through a linked list. It's a good old while such and such, do such and such, okay? So I'm gonna share this so you can just run this code. I guess I could just push it, but I'll do it on Slack because I'm living it up in the city. Let's see, create text. He's a maniac, yeah. Okay, it is shared right now in the Slack. Do we want to do this in breakout rooms? Yes or no? Yeah, let's do it. I like it. Let's do it. Nobody answered. I can feel the pump up. Oh, people are throwing yeses in. I see it's a couple people, but no. Sorry. It's too bad. We're going to do some breakout rooms. But you're welcome if your breakout room decides to be more individualistic. That's fine. Okay, let's create these rooms. I will look over the rooms to make sure they're not really crazy. Okay, options. Let's do this over the next, I think 13 minutes is a fair amount. Okay, and away we go.
It's okay, I was done. Okay.
You needed like 2 more minutes
Yeah, like maybe like
or 5.
5 minutes. I agree with Jay.
We will have a chance to do more. Well, we can take a poll, just because I was in a group that did finish.
Enhancing.
Let's see. Let's see the state of where we're at. Yeah. Okay. Okay. I'm going to release a poll. Scale of 1 to 5. 1 is 0. Okay. 2 is 1. Just pretend it's 0 to 4 on how many more minutes you would want working on this. Okay. Okay, so on a scale of 0 to 4, which is really 1 to 5, how much more time do you need? Okay. Interesting. I will share the results. Ooh, it's like so hard, not totally sure what to do. I know I will make people unhappy no matter what I decide. What a fantastic position to be in. Let's do the ultimate compromise where I make sure nobody is happy. which would essentially be if I did the 4 minutes because only one person read that, which is really 3 minutes. So I'm going to give everybody 3 more minutes so everybody can be the least satisfied. Okay? It makes sense to me. That's the ultimate compromise. Nobody wins. Okay? So we have 3 more minutes in the breakout room, and then we're coming back. Oh, hey, David.
Hello.
Hey, hello, hello, hello. Welcome back to the greatest show in the world. This is the JavaScript show. All right, let's check this out. We have to check it out. We have to go to the doctor. And we will go to our desktop too. That's a note from me. Okay. And so what went well? I guess what should we think about when we're doing this problem? What do we care about? So we have a function, and we're gonna say print, or we'll say find odds. I don't know. That takes in a head. I'm gonna call it the head of the linked list. So what do we need right off the top? What do we need?
We need a variable to hold an array.
That's right. I need a variable for my array. I need like some kind of output that's going to be an array. And I even know at the end, I'm even going to return output, right? Because that's the whole reason. That's part of the reason why I know I need this array is because that's what this function returns, right? It takes in the list and returns an array. So remember, we should always be thinking, what am I taking in? What am I putting out? If it's requiring me to put out some kind of data structure that I don't have, I should definitely make it right off the bat. Okay, so we had a while loop hint. So I'll say while. And we want to do some stuff. So what do we want to put inside of this while loop? What are we thinking?
We want to declare a variable for the current node that we're using.
Sure, I could do that. So we can call it current, and who does that get assigned to?
The head.
Okay. What else, Danny?
And for the while loop, we want to just we want to check to see if the head exists.
Okay, yeah. So we can say, hey, while current, right?
Exists. Sorry.
So in the event that someone passes in some null value, I won't even go into this while loop. So, but if I do, that means I have actually something here. I have some kind of node here, right? So who can help me with the next piece of information? Somebody different, maybe.
We need to check if the current is an odd number.
Perfect. Yeah, totally, Sam. Right. So we want to check, like, hey, if my current dot val modulo 2 is equal to 1. So if this is an odd number, what do I want to do with this odd number?
We need to push it to the output.
That's right. So can I do this? Can I do output dot push current? Are we happy with that?
Shouldn't it be the value?
No.
Excellent. Yeah, I heard Danny say, shouldn't that be the value? And I think I heard Doug give out like a no, which I like. Right? We need that value because that's what this is asking for. This isn't asking for the odd valued nodes. This is just literally asking for the odd values. Okay. So in the event that it's an odd number, we will push that number in. Do we need an else statement?
Nah.
No,
Nah. Okay. But what do I need to do next?
you need to switch to current.
Okay. I need to update the current. So let's reassign the current to what?
Current up next.
Current dot next, right? This is a super common pattern that you will see so many times whenever you're dealing with linked list problems. You will often want to use a while loop to traverse the linked list. Okay, and so let's go ahead and just test our code here. We'll say find odds. And we get 3, 5. So it works. So this is a good problem. I have a couple favorite problems with these that are on leak code, but I will tell you that when we hear linked list problems, sometimes you should be thinking about this. Sometimes think, can I use 2 pointers traveling at different speeds? Okay, that will mean more to you later when you're going through elite code problems. But whenever you're doing a leak code problem, if it's asking like, is this like, sometimes you'll just want to do something like this, while other times it will help to have 2 pointers. That essentially means I could have a current and let a fast equal the head and let a slow equal the head, and then update them differently in the while loop. That is another somewhat common scenario. Okay, any questions on this? If you can master something like this, you can definitely pass something on the exam. Okay, any questions? Okay, let's quickly also review today stacks and queues. So let's make a new file called stacks and queues.js. Can anybody tell me what a stack is? What is a stack?
First in, last out.
Sounds good. That's sin, right? First in,
Yeah.
in. What?
First in, last out.
First in, last out. Right? Stack of plates. We can think of it.
It can be done either as an array, a linked list. I think
Yeah.
there are a couple other ones.
Linked list, for sure. What is a stacks API?
Repeat that question.
What is a stacks API? I will word that another way.
Yeah,
What methods are available on any stack?
Oh, it's pop, push, pop, peek, and is empty.
Is empty. What? And you said peak, right?
Yeah.
Exactly. Okay. Let's quickly implement a stack. Okay, ready? So I have a class. We have a stack. We can make a constructor. Let's do an easy kind of version. So let's just go ahead and say this dot stack and make it an empty array. Right? And so we'll make our pop method. And our pop will just pop off the stack. So we'll say return this dot stack dot pop. Let's add a push method. So this is just going to push it on. So we'll just say this dot stack dot push our val. This probably needs to take in a value. Okay. Let's write another one. Let's say, we'll say peak, right? Peak is just going to return the last element. So it's just this dot stack at this dot stack dot last minus 1, right? No biggie. And we'll have an is empty where we can just go ahead and say return this dot stack dot length equal to 0. Okay. And this essentially should work as a stack.
Would you have to add a last property to the constructor or to the
Add a what to the constructor?
last? So is last an array method? Is that what we never use?
Last. Oh,
Or length minus 1?
length. That's what I meant. Thank you. Good catch. Typed it too fast. Any questions on this implementation? Okay. So let's write a problem for us to work on again. Write a function that takes in a stack. Hang on, I wrote down a problem I wanted to do. Okay. And finds the product of that stack. Okay. So product is all of the numbers inside of it multiplied together. I'm going to do something where I say like, as if I can predetermine a stack here, and I'll just say stack, and I'll default this to be an empty array. And that way we can say const find product, takes in a stack. I want it to do something, and then at the end we'll console log r check. We'll say find, let's make our stack. Okay, so we'll say let stack is equal to new stack, and we will pass in 1, 2, 3, 4, 5. So I don't want you to use this as an array, right? I don't want you to iterate as an array because it's not, it's a stack. So I want you to do find product of our stack, okay? Any questions on what I'm asking? And I will share this code as well on the web.
Okay.
Slack recently changed a couple things, so it's more confusing to me. Okay, I'll also push this. If there's no other questions, we will go back into our BR rooms, our BORs. Okay, that's what the kids call it, and I am very, very young. So options, let's go ahead and give ourselves, let's try to push ourselves and give ourselves 12 minutes this time. Okay. See you all in a jiffy. Welcome back, Karen.
Hi.
How you doing?
That you cannot don't pay it.
All right. How did you do? How did your group do? Let's relaunch this poll. Scale 1 to 5. How did it go for you? How did it go? Did it go for you? Yeah. Let's see.
Sorry,
Here.
5 is for completion.
5 is for completion. Sure. Yeah.
So Corey,
So Danny,
with our group, we got it, but we were then challenged to do it recursively.
Hey, cool.
That's when it started.
Whoever challenged you don't love you, bro.
That's a great challenge.
Started getting crazy. Almost there.
it.
Almost there.
Share the results. We did well as a class. let's go over it and share our screen. Okay, I'm going to assume that my stack class was written correctly. I hope so. Otherwise, we're going to have some debugging to do. Okay, so we can't do just like a traditional for loop here, right? I mean, I know we have a let prod for our start with 1 because any number times 1 is any number. And I guess if my stack is empty, I should probably return 0. So if stack dot is empty, we can just go ahead and return 0. Otherwise, we can let our product equal 1, and then let's go ahead and iterate through this. So if we can't use a for loop, what kind of loop should we be thinking about?
Wow.
Yes, while we're at it, let's go for while, right? So we'll say while, and then when do we want to stop?
While the stack isn't empty.
Yeah, sure. So when stack is while stack is not empty, so we'll throw in a bang operator there. So while it's not empty, let's go ahead and just keep updating our product to be times equal our stack dot pop, right? So we'll take off an element. Then at the very end, let's just go ahead and return our product. And let's give this a shot. This should equal like 120 or something. What? This is 3.5. This is like, oh, this is still running the node one.
Yeah.
Okay, that makes more sense. 120. Okay, cool. What might we care about? What might suck here?
Mutations.
Mutation, yeah, right. Mutation might suck here. If we don't want to mutate, we're going to have to figure out some other way. So maybe we fill up an array and then put things back into its stack once it's empty. Or maybe we fill up another stack, right? There's no reason why I couldn't do like let temp stack equal new stack. And then instead of just directly popping, I can save it, let element here prod times equal element, and then temp stack dot push element. So then my stack is going to be upside down though, right? So I could then put it all back together if I wanted to. Well, I could say while not temp stack dot is empty. And then I would just be doing my original stack dot push of temp stack dot pop. So if I do that, I can still then after I run this function, I can run console log stack, and I should be able to still see that I get my 120, and I still have a stack, my original stack. So it's uglier. What we wrote first is probably what would be like required of you on the test, but this is something just to be aware of, because as you do solve problems, this is something to be thinking about. Am I ruining the data that's coming in? It does show up sometimes. Danny, did you want to do it recursively? Is that why you brought that up?
So,
I don't really want you to solve it.
Oh, okay, great. That will be, I'll have you do it tomorrow. Maybe that will be the warm up on Saturday or Sunday. Just to do it recursively. Do recursively. Okay, so now let's talk about what a queue is. Queues. What are they all about? What is a queue? What is going on? I hear like all this crazy.
It's
First in, first out.
Am I in somebody's pocket in their phone? I'm gonna figure out what's going on with that sound. That is a mute. Why am I not able to mute you? Hey, Ashia, can you mute yourself? For some reason, I can't seem to mute her.
On Myrtle Ave?
Hey, Ashia. Can you please mute yourself?
Sorry, I'm mute.
Okay, thank you. Man, there's a lot of action going on over there. I think she's chopping up a human body. Okay, what is a Q? Let's talk about the Q. Can anybody tell me what a Q is?
Isn't it like the opposite of stack?
Yeah, but what does that mean?
FIFO.
Last in, first out?
First in, first out.
First out.
First in, first out. Yeah, FIFO, kind of like FIFA, right? First in,
Not even close.
first out. That's the soccer head docket. All right, first in, first out. Real life example, a line to get into the queue, right? That is like a queue, right? These are fair. That's something to think about. These are fair, while stacks are not necessarily fair. Not fair. Okay. What is a queue's API?
NQ,
NQ.
DQ,
I love DQ. Yeah.
Is empty.
Is empty, and peak.
And peak. Okay, so the task. Write your own queue class. Okay. And then, if you still have time, actually, just do both. Write a function that takes in a queue and returns the largest value in the queue. Do not leave the queue mutated. This is bonus area. Okay, so do not leave the queue mutated. Do the previous problems recursively. Linked list 1 included. Okay, that should keep everybody busy. If not, kudos to you. I will share this right here in the chat. Okay, any questions before we get going? Let's try to do all of this. What's a reasonable time frame? 15 minutes?
1 hour.
What? John, did you say something? Oh, no. All right. Henry, did you say something? People with the mutes. Okay, we're going to go with 15 minutes. All right, let's do it. Ashia, it says you're unassigned. Which room were you in prior?
I was in a room with Doug, Karen, and David.
Doug?
Oh, because I'm on my phone. I had to
no
make
problem.
a quick reference.
Breakout room 4. Okay, there you go. Trapped down here for a while.
Oh, we were trying.
Hello, everybody. Hello. How we doing? How we feeling? How did this go on a scale of 1 to 5?
More time.
I was in your group. I hear you, but I could tell that you guys were on the right path. Okay, let's see here.
Yeah, we need more time for the bonus part.
For the bonus, yeah, okay. Yeah, let's go over the basics and then maybe we can do a little, let's like build out the class at least, and then we'll go back. So it's not all one shot. In the poll, share the results. We're living in the 3s with some 5s. All right, so let's take a look. Let's do a little dance. Make a little love. Get down tonight. Woo! Yeah. Hey now. All right. So let's at least start off by writing a cool Q class. So we got our class. We got it called Q. Let's give it a constructor. And we can say this dot Q is equal to, and I'm going to go ahead and make it take a Q in as well, just so, and it will default to an empty, just so I could, excuse me, that so I can more easily test this. So we talked about its API, InQ, DQ is empty, and peak. So let's just go ahead and blow those out of the water. So we've got our InQ, and it takes an eval, and I could either unshift it or push it into this array, right? So I'm going to go ahead and just push it in though. So I'm going to say this.q.push val. I get to decide if I want my InQ to return something or not. For now, I'm just going to have it not return anything because it doesn't really need to. I could have it return the new length. I could have it return true or false, depending on if it was empty or if it was successful. It's kind of up to how you decide to design it. We've got our DQ. This has to take from the front because we're pushing to the end. So that way we keep having this like list, this where it keeps going one direction. So we can just go ahead and return this dot Q dot shift, which is the opposite of push. Let's do our peak, right? Peak is our method. This is like peeking, as to look, like getting a glimpse before we buy. And we can just go ahead and return this dot Q at the index of 0, because that's the first element. That's what will be shifted. And we have our is empty, which we can just return this dot Q dot length equal to 0. And we should have a successful Q. Okay. So I am hearing more time. But before we do that, are there any questions on this Q?
Corey?
Yes.
For DQ, right? I was looking at one of the previous DSA lectures we had with Jonathan, and he wrote it as return this dot Q dot pop. Would that?
This is Jonathan Andrade you're talking
Sorry,
about?
I keep forgetting his name. What's the volunteer?
Daniel?
Daniel, yes. Sorry.
Daniel. Oh, no. So if he's writing pop here, then this must have been unshift, right?
No, he wrote. Maybe I just wrote it wrong, but because I had NQ is this dot Q dot push, and then DQ is this dot Q dot pop.
Okay, so that is the behavior of a stack. So either you wrote it wrong or he wrote it wrong. Unsure.
I definitely wrote it wrong.
When we did it with Daniel, we went over doing queues in multiple ways. Arrays, stacks, linked lists. So you might have one of the different ways.
Oh. Oh yeah, I have it as a linked list. I think that's what happened.
So so your linked list might be doing something else.
Okay.
As long as it's moving in that line order.
Got it. Okay. I think then that would be
first down.
The undefined we had. Okay.
Any other questions on this sector here? Okay, so let's give it 5 more minutes and try to pound out the rest of these. Okay. So going back into the breakout room is where I belong. 5 minutes, and we will open the rooms. And I'll see you later. Sin, I see you're unassigned to a room. Do you remember which room you're in? It's the greatest show on earth. How did that go? How did this go for you?
Are we talking about the like just the main goal of getting?
Yeah, let's talk about the main goal.
In that case,
because I know everybody made it to different lengths. We'll give you a really cool hint that you guys might want to know about, which is like the problems that I gave you today would be very good to get comfortable with if you wanted to do well on the DSA test. There's
Quick
probably
question.
a comparable one for each one that I gave. Yep.
Quick question. Do we have to write out our classes for our queues and our stacks? And
Not for the test, but that's definitely something that you should know how to do.
Okay.
Brandon, I don't remember the test date off the top of my head, but I think it's in Canvas. Maybe someone who has easier access to Canvas right now. This is where we're at, 3s and 4s. Brandon, I can get to Canvas. It is, I think it's been moved to the 13th. So we have a little bit more time to go over things. That's great. That's great. That's really exciting. But don't put it off. But that means I can pace things the way I want to pace them, which I wasn't happy with before. Excellent.
I appreciate it.
What? Okay, that's great. Oh, I'm so freaking excited. Is it separate from the unit test? That's a great question, Brandon. Yes. So we have a DSA exam, and this unit test is really going to be called a comprehensive technical assessment. That's going to be the CTA. The CTA, we are still in the process of designing it. Me, Jenny, and John all agree we don't want the CTA to be the same thing that 6.2 did. The thing is like in previous classes, they've had the CTA, and like last year we did it and we got all of the same, everybody did this exact same project and test, and it's a full stack application that you have to build. So I really don't want that this year because I don't want everyone to build the same thing. I want people to build things that follow the same guidelines and requirements, but that are different projects so that people can actually use them on their portfolio and projects and resumes instead of it just being some test. So it's still being designed, but that is separate than the DSA thing. Okay. Any other questions on that? I'll know more. I'll be able to tell you more in the future as well. But for now, so we're going to be in a better position than 6.2. That's always my goal. I'm super competitive against them. Don't tell them that though. I am like hyper competitive as an individual. Okay. Let's see. I see some chat stuff going on. LOL. Yes, everybody knows I'm competitive. If you didn't, I don't know where you've been, but okay, let's go ahead and write this function that is going to return the largest in the queue. So let's write a function called const, and we'll say find max. That takes in a queue. And what should be the overall kind of approach to this? What should I be thinking about?
Keeping track of the max.
Yeah, so I should definitely keep track of a variable that I'm calling max. So let's go ahead and make a max. And what would be a good idea to start this variable as?
Negative infinity.
I heard somebody say something that I liked. It was a female's voice. I couldn't quite hear it though.
Negative infinity.
Negative infinity. That's Maria, right?
Mm-hmm.
Yeah, exactly. I think negative infinity is great. And thanks, Giovanni, for writing that in the chat as well, right? Negative infinity is good because any number that I compare negative infinity to, if I say like, hey, is this number bigger than this? Negative infinity will always lose, right? So even if the number in the queue is negative 3,000, negative 3,000 will then be our max. While if we would have started at something like 0, we would have been like, oh, 0 is still bigger, but 0 is not in the queue. And on that same note, we should probably protect on the case that I don't have anything in the queue. So I can just do a quick like, hey, if q dot is empty, let's just go ahead and return null, I guess. I don't know. Depends on what we should return. That's a good like interview question, is like, what should I return if my queue is empty? Maybe it is negative infinity. Maybe it's null. Maybe it's undefined. Maybe I'll just return. So it will be nothing. In the meantime, though, let's go ahead and write the rest. So how can we loop through this queue?
While.
Yep, I like that. While we're at it, let's do it. So we'll say while q dot is empty, or specifically not empty, we can go ahead and update this max. So we can say max is equal to math.max, and we can put in the old max, and we can also just put in our q dot dq. Right? So this is constantly updating our max to be whatever number is the largest. So I don't even need an if statement, right? If you put if statements in there, that's totally fine. That's normal. I just want to show you another way of writing it. This math.max and math.min can become a very, very powerful tool, especially as you start solving more and more complicated problems, like dynamic programming kind of problems and things like that. You'll often find yourself reaching for math.max and min, so you don't have to constantly do comparisons. You can just always take whichever thing is bigger. So it leads to more efficient code. And then at the very end, we can just go ahead and return our max. So let's give this sucker a shot. So let's make a queue. And I will say new queue, and let's just pass in some numbers. Okay, and let's try this out. So we will log our find max, and we will pass in our queue, and let's give her a shot. And we get 25. Huzzah! We were successful. Any questions on this?
So with how exactly does math.max work? So like max
Sure.
just
So what math.max is it takes in a series of arguments and it evaluates to the largest of those arguments. So to demonstrate, let's say I console.log math.max. I could pass in I can pass in as many arguments as I want. And this will evaluate to 6 because 6 is the largest number in that group. Math.min works likewise, but the opposite. So we'll get a 1. That 25 is just from our find max. So here.
got it.
Why is it doing that again? I didn't save. Okay. So that's what these are doing. So essentially this is just taking what my old max was because I don't want to forget it. And I'm taking, I don't know how that even happened. And then, so it's taking this old max and it's taking the new value to compare. And it's just going to evaluate to whatever is the max between these two numbers.
Got it. So each time, technically, it's just comparing two numbers at a time.
That's right.
Choosing.
Yep.
Okay.
And it's choosing the larger of the two, right? So if there is a problem on the test like this, something like this would be very good. This would be fine. I'll tell you something that we don't want to see. If you feel like being super clever, please don't. Just do something where you're like, oh, math return math.max of q.q if you look at how this is made, right? Because like yes, that will technically also work, but that's really defeats. Oh, it didn't work. Oh, hey. Why didn't that work? Because I didn't destructure it. Because it's an array. So that technically works, but like you should not ever be like keying or like accessing an internal property that's not supposed to be exposed. So that would really be taking advantage of the fact that you can see what I'm calling that in this class, because you know I'm calling it a .q. So you shouldn't be able to access that because that's not really part of the Q API. You should write problems like this. Okay, I'm sure nobody will try to do the other way, but just want to make sure that that's clear. What might suck about this?
I have a quick question. For Max, why didn't we use the peak?
Ooh.
What do you mean by that?
Like set
Why
it equal
didn't
to
we-
the first value.
Oh, yeah, that sounds great. Q dot peak. I like that even more. I like it even more. Why didn't we? I hadn't thought of it. I think that's a great answer. Cool. I like it. And it uses more of our stuff, so that's pretty cool. What might we not like about this?
It mutates the queue.
Yeah, it mutates the queue. So I'm not going to do it now because I do want us to have time to like work up individually, but I want us to just be aware that if we didn't want to mutate the queue, we would have to create a new instance of the queue, pass these dequeued items into that, and then pass them back into our original queue afterwards in like a separate while loop. Very much like how we dealt with our stacks here. It'd be very similar. And I encourage you to build that on your own. And if you have trouble, reach out to me. Okay. Any other questions? Okay. Cool. Cool as a cucumber.